Our universe is weird, like, really weird. We once imagined distant planets as Earth-like, orbiting friendly stars in familiar systems, but as our telescopes improved, we discovered worlds that shattered every expectation, planets that defy physics, chemistry, and even our definition of what a planet is. These aren't just odd versions of Mars or Jupiter, they're realms so bizarre they sound like science fiction. Today we're exploring 5 of the most extreme planets ever found, worlds that will blow your mind. Get ready to journey to the edge of exoplanetary science, where beauty and danger collide. Our first stop, HD 189733b, looks like a serene blue world from afar. But that blue isn't water, it's the color of death, caused by silicate particles in the atmosphere. These particles scatter blue light, giving the planet its stunning hue. But up close, it's a nightmare. A gas giant, orbiting its star in just over 2 days, heated to 1,000 degrees Celsius. At these temperatures, silicate particles melt into droplets of molten glass. Imagine clouds of liquid glass swirling in a superheated haze. The planet is tidally locked, one side scorched by eternal day, the other frozen in endless night. This creates a massive temperature difference, driving winds over 7,000 kilometers per hour, 5 times the speed of sound. The result? It rains molten glass, not down, but sideways, whipped by supersonic winds. Any probe would be shredded instantly by the glass storm. The beautiful blue is a warning. This is one of the most violent, inhospitable places in the universe. On Earth, the strongest tornadoes reach 500 kilometers per hour. Here, winds are 14 times stronger. No life could survive. Heat would vaporize you, and glass would flay you to atoms. From 63 light-years away, it's a pretty marble. Up close, it's a vision of hell. The same physics that create its beauty make it deadly. The universe doesn't build worlds for us, it builds them by the rules of chemistry and physics. HD 189733b is a cosmic monster, a world of fire and wind, forever trapped in a storm of its own making. It's a beautiful blue nightmare, floating in the silent darkness of space. Next, a world that sounds like a treasure hunter's fantasy, a planet made of diamond. Meet 55 Cancri E, a super-Earth twice the size of ours, orbiting its star in just 18 hours. Surface temperatures are hot enough to melt lead, but the real story is inside. This planet orbits a carbon-rich star, and models suggest it's packed with carbon. Under immense pressure, carbon forms diamond, possibly making up 1/3 of the planet's mass. Imagine mountains of diamond, stretching for miles beneath a thick hazy atmosphere. The star-facing side is a broiling 2,400 degrees Celsius. The far side is cooler, but still scorching. Deep below, the pressure crushes carbon into a dense crystalline layer, thousands of kilometers thick. Could we mine it? Not a chance. The gravity, heat, and toxic atmosphere would destroy any equipment instantly. Even if we could bring back a fraction of its diamond, it would make diamonds as common as gravel on Earth. The true value of 55 Cancri E is its impossibility, a cosmic vault that can never be opened. Its existence shows that planetary chemistry can create worlds utterly unlike our own. While our solar system built rocky planets, others might build carbon worlds, alien in every way. 55 Cancri E is more than a curiosity, it's a new category of planet. It forces us to imagine what other exotic worlds might be out there. Sapphire planets, metal cores, unearthly minerals. We can't bring back its riches, but we can marvel at its existence. A planet of diamond, burning bright and forever out of reach. What if a planet was hotter than most stars? Welcome to Kelt 9b, the king of hot Jupiters. This gas giant, 3 times Jupiter's mass, orbits a star twice as hot as our sun, at a perilous distance. Its dayside reaches over 4,300 degrees Celsius, hotter than a red dwarf star. At these temperatures, molecules are ripped apart. The atmosphere is a sea of dissociated atoms. The planet is tidally locked, with a permanent dayside glowing like a white-hot plasma. The energy is so intense, the atmosphere boils away into space, forming a massive tail of vaporized material. Kelt 9b is losing up to 100,000 tons per second, slowly evaporating under its star's relentless glare. In a few 100 million years, it may be stripped to its core, or obliterated entirely. The night side, though cooler, is still a hellscape, possibly with clouds of molten iron and titanium. Kelt 9b pushes planetary science to the limit, where chemistry is rewritten by heat. It's not just a planet, but a process of violent disintegration. When a world is hotter and brighter than many stars, what does planet even mean? Kelt 9b is a stark reminder. Stars can be creators or destroyers. After fire and glass, let's visit a water world, though not the paradise you might expect. GJ1214b is a super-Earth, larger than ours but much less dense. Its low density hints at a composition dominated by water. Scientists believe it's a globe-spanning ocean, thousands of kilometers deep, with no dry land at all. But this isn't an ocean you could swim in. The planet is wrapped in a thick, steamy atmosphere, with surface temperatures around 230 degrees Celsius. The pressure is immense, blurring the line between liquid and gas. There's no clear surface, just a transition from soupy steam to hot, dense water. Dive deeper, and water becomes something stranger. Exotic ices like Ice 7 and Ice 10, solid at hundreds of degrees due to crushing pressure. The core may be a ball of this hot ice. Between the ocean and the core, there could be supersonic water, where oxygen forms a solid lattice and hydrogen flows like a liquid, making the water electrically conductive. Could life exist here? Maybe, deep within the ocean, where temperature and pressure are just right. GJ1214b expands our idea of habitability. Maybe life doesn't need a rocky surface or gentle sun. This world is a laboratory for the physics of water, showing us that H2O can form states as alien as any science fiction. It's a planet both familiar and utterly bizarre. A world of steam, hot ice, and metallic water. What if a planet had no star at all? Meet PSO J318.52 the Lonely Orphan. This rogue planet, about 6 times Jupiter's mass, drifts alone through the galaxy. No sun, no orbit, just endless night. It was likely ejected from its home system by a gravitational encounter, sent on a one-way journey into the void. Without a star, it's incredibly cold, but not frozen solid. As a young planet, it still glows faintly in infrared, warmed by leftover heat from its formation. From its cloud tops, there's no sunrise, just the brilliant sweep of the Milky Way and distant stars. The planet's storms are powered by internal heat, not sunlight. PSO J318.522 was one of the first free-floating planets ever directly imaged, proving these lonely worlds exist. For every star in the Milky Way, there could be dozens or even thousands of rogue planets, trillions of hidden wanderers. Some may be gas giants, others icy super-Earths or barren rocks. It's even possible that, with thick atmospheres or subsurface oceans, some could harbor life, surviving in total darkness. PSO J318.5-22 is a symbol of cosmic loneliness, but also resilience. A world glowing faintly as it drifts through the interstellar night. It opens a new frontier, the study of the galaxy's dark hidden corners, and the lost worlds on their own epic journeys. From diamond worlds to glass storms to planets without suns, the universe constantly surprises us. Each strange planet is a clue, showing us that the rules of world building are more creative than we ever imagined. These discoveries expand our sense of what's possible, and prove that reality is stranger than fiction.